Hello. So we're going to continue our discussion of dynamics. This time we're going to be doing some problem solving. So we're looking at problem 3. Problem 3 deals with a box with a mass of 45 kilograms that you're pushing across the floor. I give you the applied force of 225 newtons. And I tell you that you're moving the box at a constant velocity. This automatically tells me that I'm dealing with a situation where the forces are balanced. The question that you're asking yourself is, what is the coefficient of kinetic friction? Kinetic friction meaning that the object is moving or sliding in this case. So go ahead and get your problem solving sheet out. We're going to go ahead and walk through that for this particular problem. First part of the problem solving process is to draw a picture. We always draw a picture of what is going on to focus the problem. In this case, I have drawn a picture of the box and I've labeled all the forces acting on that box, which includes the weight pointing down, the normal force, which is always going to be perpendicular to that surface, pointing up. This is going to be the force between that the floor exerts on the box. Then we have the frictional force and the force that you applied. With my drawing, I also label all of the known information, which is the force applied and the mass. So the question, what is the question that's being asked for this problem? Because we always want to answer the problem that's being asked. In this case is, what is the coefficient of friction? The coefficient of friction is represented by the mu. We have the subscript k there to represent that is the kinetic friction. SI unit should be unitless. So coefficient of friction is a unitless value. So the question is then, what concept do I need to answer that question? And I'm going to use kinetic friction or friction to answer that question. Okay. What relationship do I need? I'm going to use the relationship of frictional force is equal to the coefficient of friction times normal force. Lowercase f is equal to mu sub k times f of n. Okay, so that's the focusing the problem. So then I'm going to describe the physics. First, I'm going to draw a free body diagram. Free body diagram starts with a coordinate system. A coordinate system where I have x going off to the right, the y going up in a positive direction. So I put a dot at the center, at the origin, and then I draw the applied force going in a positive x direction, frictional force going off in a negative x direction, with the normal force, positive y, and weight going down in a negative direction. I then write my known and unknown, my defined quantities and my target quantities. What the problem gives me is the mass and the applied force. The target quantity or the unknown quantity is the coefficient of friction. After that, I then check to make sure I'm in the proper SI units, which I am. Masses are in kilograms and forces are in newtons, so we are fine there. We don't need to do any unit conversions. Next, I want to plan the solution. Again, when I plan the solution, I do not include numbers. This is just the equations. So I start with the one from my relationship, and I'm going to go ahead and solve that for mu. Okay, so if I can solve this one, I'm finished. But what I realize is that I don't know the frictional force. Don't know the frictional force, neither do I know the normal force. So I need another concept which then will allow me to solve for those values. Okay. So since we said we are dealing with balanced forces, I can use the concept of Newton's first law. Newton's first law says that the sum of the forces will equal to 0. So I'm going to first sum all the forces in the x direction. Going back looking at my three-body diagram, I noticed that the only forces I have is the applied force and the frictional force in the x direction. So I then get sum of the forces in the x direction is going to be equal to that applied force minus the frictional force, which will equal to 0. I'm going to go ahead and solve for the frictional force. Frictional force is going to be equal to the applied force. I know what the applied force is. They give that to me in the problem. So I now know what the frictional force is equal to. So now I want to go ahead and do the same thing for the y direction. I want to sum all the forces in the y direction. Looking at my free body diagram, I get the weight in a negative y direction, and I get the normal force in a positive y direction. So go ahead and sum those. So the sum of the forces in the y direction will be equal to the normal force minus the weight, and that again is equal to 0 because they have to balance each other out. So again, I want to solve this for the normal force. So F of n is going to be equal to W. But what's unknown is W. They do not give me the weight of the object. They give me the mass of it. So now I can use Newton's second law to find the weight. Second law says the sum of the forces is equal to the mass times the acceleration. This case, the force is going to be weight. It's going to be equal to the mass that they give me times g, which is the acceleration due to gravity, which I know is 9.8. So now I know the weight. So I can now plug that into this equation, and I now know what the frictional force is. Once I know the frictional force, the normal force, F of n is the normal force. Once I know the normal force, I could then plug that in to my original equation. I know what the frictional force is because I know what the applied force is. So now that I know that, I can then plug that in also to my equation, and I can solve for mu. Okay. So again, I'm using 3 different concepts to solve this problem. But now I can go in and plug numbers in. So to execute the plan, I start with the weight. I plug those values in and I get a weight is equal to 441 newtons. The weight was equal to the normal force. Frictional force was equal to the applied force. So now I know that mu, coefficient of friction, is going to be equal to 0.51. To finish off my problem solving, I have to evaluate the answer. Does my answer answer the question that was given? Is it reasonable? Is it complete? So I said, yes, it is properly stated. No, it is not unreasonable. And yes, the answer is complete. So again, my answer is 0.51. Okay, so again, this was problem number 3. So go ahead and start problem 4, and we will discuss it in the next video. Thank you.